A rough graph of the polynomial function f of x equals x minus 2 times x plus 3 squared. Hint: find the x and y intercepts and plug in other points. Scale the provided graph paper as necessary to fit the graph. So I didn't put any labels on it. You can label it any way you want to make it fit what you're doing. So don't forget everything we've learned just because we're moving on with new stuff. So x-intercepts can simply be found by taking the factors and setting them equal to 0. And if it's not already factored, then you factor it first. And that's part of what we're going to be talking about in this chapter, not necessarily all in this section, is how to factor polynomials. Okay, so let's start by taking the factors they already gave us. X minus 2 equals 0. That means x equals 2. And then we have x plus 3 squared equals 0. The squared doesn't really accomplish anything in this case. It just means we're going to have a 0 at x equals negative 3. Now I'm going to jump the gun on telling you about something and what it's called. This particular 0 has a multiplicity of 2. And the reason I say it has a multiplicity of 2 is because it's squared. So it would be the same 0 for both of those factors, x plus 3 and x plus 3 would give us the same 0 twice. So we call that a multiplicity of 2. Okay, let's go ahead and, I don't know if you remember this from a previous problem, but we found that constant term by multiplying this stuff together. So our constant term is negative 2 times 3 squared. So close, but you got to square the 3 because of the square. Yeah, thanks Dominic for jumping in. So what is it instead? Revise your answer slightly. Nope, we're doing negative 2 for this term right here and 3 for this constant, but squared. So negative 2, yeah, there we go, negative 18. So do you see why I said in the question you may need to scale the provided graph? Because if we want to actually graph negative 18, it's not really going to fit on here very well. So maybe if I count by 3's on my y-axis and call that point right there negative 18, and then that can be my y-intercept, right? David, it's okay. You probably have been trying to do too many things. You're good. Okay. Let me see. So we have zeros. We have a 0 at 2, and we have a 0 at negative 3, and we have a y-intercept at negative 18. We can plug in some other points to figure out what this graph is going to look like. That might take a few minutes to plug some other stuff in. In a few minutes, we're going to learn some other characteristics, but I'm not sure why we don't put those in the book first. I think they kind of like to let you explore the stuff first before you learn the rules, but I'm going to jump the gun on this other one. So the leading term, I wish I had that in a different color. The leading term is going to be x times x squared, right? So x times x squared. So the leading term will be x cubed, and the coefficient would be 1. So the leading coefficient would just be 1. Well, I happen to know that the x cubed toolkit function graph looks like this. Remember? Back from chapter 1, we know it kind of looks like this. So this graph is no exception. It's going to sort of look like this, except it's going to have an extra bend in it because of the extra numbers. So the negative 3 has a multiplicity of 2. I don't know if you heard me mention earlier that when it has a multiplicity of 2, that means it's going to behave like a quadratic at that point. So a quadratic goes up and back down, or down and back up, right? It has that vertex. So same thing, this side of our graph has to be going downward, and we're going to learn more about why that is in a minute. And then this point has to act like a parabola within our graph. And then this is our y-intercept, and this is another 0 over here. So if we were to plug in some other points to kind of see what this graph looks like, we would find out, and I have graphed this horribly, and this is where Desmos can kind of help you out to see those characteristics. It should look a little bit like that, only without this corner. It should be more rounded. I just want to try one more time just because I hate that it's not very good. I actually did a table of values in my paper. To save us time, I'll just go ahead and show you the table of values I came up with. So if you're creating a table of values, it's good to pick numbers on each side of things that you don't know where the graph is going. So we know the graph is going to be right here at this point, and we know the graph's going to be right here at this point, and we know the graph's going to be right here at this point, but we don't know for sure what's happening over here, or once we get past here. So let's plug in some other numbers. So like an x value of 4 might be helpful. So actually it's a negative 4, isn't it? It's a negative 4. If I plug that into my function, negative 4 minus 2 is negative 6, and then negative 4 plus 3 is negative 1. Negative 1 squared is positive 1. So we get a negative 6 times a positive 1, and that gives us a negative 6. So that verifies, remember this direction I'm counting by 3s? So that would be negative 6 right there, because we're counting by 3s. So this point right here tells us that our graph is going that way. Let me just throw in some other points that I've already prefigured, but it would just be taking those points and plugging them into the function, getting an answer. So if I plug in a negative 2, I get a negative 4. So negative 2, negative 4 would be about here. If I plug in a negative 1, I get a negative 12. See how that's heading down toward that y-intercept. So somewhere in there. If I plug in a positive 1, I get a negative 16. So now it's coming up from our y-intercept. It'll end up being around there. And then a 3, the reason I chose a 3 is because it was beyond this point. So plug that in and I get a 36. So at 3, it's going to be clear off the graph up here, twice as high as that negative 18 is going this direction. So that gives us a graph. That should not be all curvy like that at the end. That's better. Okay. So I kind of had it figured out right, just because of the multiplicity of 2 at that point and the multiplicity of 1 at this point. It crosses through here. It goes through the y-intercept. I missed the y-intercept, didn't I? There, that's better. So you put all the little pieces together. Now, how did I choose the numbers that I put in for x? How did I choose these right here again? Why did I skip 0? Why did I skip negative 3? Why did I skip positive 2? I skipped those particular numbers because I already had the points at those numbers. I already had the point at negative 3 and the point at 0 and the point at positive 2. I was trying to fill in some gaps. Yep, so choose x values to fill in the graph. All right, let's see what our next example looks like. Oh, that's just talking about multiplicity. Okay, we'll do that one after. Okay.